Okay, students, so we're working on direct variation. There's going to be 4 or 5 labs going on at once, so I did some video directions so I didn't have to take a lot of class time. So if you're watching video directions right now on the tin experiment, you're in the right place, so that's good. Okay, now I'm actually not going to do the lab per se. I wanted to show you a little bit about how the equipment works, so hopefully that'll make sense. And everything's written in the lab, so feel free to read slow, don't get overwhelmed, okay? But I'm hoping that this will give us a little bit of a leg up on how we go. One of the things you're asked to do is to weigh a random sample of tin, okay? So this little medicine looking jar is your tin. It looks like buckshot, for those of you that know what that looks like, okay? And this is an electronic balance scale that's going to actually calculate the mass of the tin, okay? Mass and weight aren't exactly the same thing, but mass on the planet Earth and weight, they act very similarly. Feel free to ask a physics teacher and they'll give you a dissertation on it, which will be quite wonderful. So here's the deal. Get this guy plugged in. We're going to put this little glass on it. Now it's weighing the glass, so it's got this cool button here that says on, 0, off. So when you put the glass there and hit the button, it actually resets the scale to 0. So you want to see that 0. Actually, this one says 0.0010, so I'm actually going to re-zero it again, ask the computer to calculate it. Okay, and then I think if I take a look, this lab said to weigh a random sample of tin more than 10 grams but less than 25, okay? So this is what we mean by random. Before we get going, let me put my safety goggles on just in case anything explodes. That's not going to happen. I'm just kind of teasing you. So, make sure we're zeroed properly. Good. And just going to add some tin until we get between 10 and 25. Okay. Okay, so there we go. This is 13.62. 13.62. Okay, there we go. So the deal with that is now that I've got a good random sample, in the lab there's a place for you to record that, okay? So the next thing you actually have to do is to find the volume of that. And you're going to do that by doing a water displacement with a graduated cylinder. So I guess what we'll do here is we'll put somewhere between 4 and 6 milliliters of water in here. And wherever it is, it really doesn't matter. It's anywhere between 4 and 6. But you do have to take a measurement of it. So anywhere between 4 and 6 milliliters, I guess, is pretty good. If it doesn't work, we'll try it again. Now there's a little sort of bubble on top of the water that's called the meniscus. So when you go to read that, you read it from the top of the meniscus, okay? And this says that it's 4 point, every slash on it is a tenth. So it's up to 4.8 milliliters, okay? So 4.8 milliliters of water. There's a place you actually record that. There's a little graphic organizer on the lab that'll help you do the volume, okay? So what we need to do now is, now that we've got that 4.8 recorded in the lab, we're going to use a funnel. Carefully pour in all of your tin shot. You have to make sure you get all of it in because that's the mass that you use. So you have to find the volume of the mass that you use. Now, the water's obviously gone up. Okay, so you're going to measure that again. Take a measurement. This is as 6.7 milliliters. Okay, so on the lab there's a graphic organizer for this. It'll show you how to compute the volume of just the tin. Well, it makes sense if you have tin and water and you take out the amount of water you started with, then it's just going to tell you how much tin is there. What we mean by how much is the volume of it. Okay? That graphic organizer is actually going to look a little bit like this. It says here the volume of the H2O, that's what you started with. That was 4.8 milliliters. Okay? Yours is going to be different than mine. Then it said the volume of the tin and H2O together. So after I put in the tin and the water went up, I'm looking at that, and that's 6.7 milliliters. So if I do that subtraction, I am going to get what? I'm going to get 1.9 milliliters of tin. Well, milliliters cubed. Its volume is a three-dimensional type idea. Now, it doesn't mean I cubed the 1.9, it's just part of the unit. Okay? Areas are like centimeters squared, volume can be milliliters cubed, volumes of solids could be like centimeters cubed. So, this was the way we did the volume of the tin, finding it by submerging the tin in water in a graduated cylinder. So, pretty cool math. Very ancient method, believe it or not. So, it's cool that you guys are still using it with various technologies that are not so ancient. Now, the rest of the lab is pretty straightforward. You're going to use this information that you gathered here with this equipment and put it together with what we've learned about direct variation. You're going to make some graphs, you're going to build some equations. You're going to use those graphs and equations to predict other measurements that you actually have not taken. You're going to do some predictions on what would happen given these graphs and equations. Then you're going to come back to this equipment and actually sort of rerun the experiment and actually see if those predictions were correct. So in review, what you've done here is you've taken some measurements, built some equations to make some predictions, to come back and take more measurements and see if those predictions were correct. Okay? So this is where the science hits the math, and hopefully we've done something interdisciplinary here, and I can't wait for you guys to get cracking on this. See you soon.